Welcome to the Sales and Tech Connect session called SDN, What You and Your Customer Need to Know. My name is Jamie Weaver. I'm on the Networking Product Marketing team, and I will be presenting this session. Today's agenda is rather straightforward. We'll open with the origins of SDN, provide a working definition, and understand what is driving SDN today. Then we'll talk about some specific SDN technologies and look at different models being proposed and in some cases deployed. The remainder of the session will be spent understanding Avaya's direction for SDN. Understanding its roots is helpful to understanding the technology direction of software-defined networking. As researchers in some large California universities began sharing applications and information, they became frustrated with the slow implementation times of their network requests. So they set off to find a better way. From this, it's easy to see a clear academic influence in the SDN movement today. Key principles such as openness, being vendor agnostic and cost effective, and being application developer centric are key signs of the academic influence. The Open Networking Forum and spin-off companies from university projects are still a driving force today. Let's understand where SDN is in its development. To illustrate, this slide is created from what Gartner calls its hype cycle diagram, and the yellow circles represent their opinion. Every technology goes through one or more stages in the hype cycle. At first, many technologies seem promising and are overhyped versus their true business value. As a consequence, the technology loses some of its luster as it tries to find its true value to companies or consumers. If the technology doesn't find its fit, it fades away. If its value to the market reacts, or if it finds its value to the market and the market reacts positively, it reaches the plateau of productivity. With SDN only being about 2 years old and due to where it's at in its technology development, Gartner has placed SDN as a rising technology. It has some distance to go before it's accepted fully in the market. Now that we have some context of where SDN is in the market, let's look at what your customers are thinking. A recent survey provides a view into customer mindsets regarding SDN. The big picture is that the great majority of customers have some kind of engagement with SDN. The majority are actually in this exercise of trying to understand how it will provide value, while just under 20% are actually evaluating it. Interestingly, only 5% have deployed, and we know that most of those deployments are with very large, sophisticated organizations like Google, Apple, and Rackspace. The bottom line is that you don't need to be an SDN expert in front of your customers, but you do need to understand it and be able to explain Avaya's direction in this space. So really just to recap, SDN's come a long way in a short amount of time. There are a wide range of consortiums focusing on it today. The industry is starting to pick sides in terms of technologies and consortiums. And really where a lot of activity is happening today is around the creation of these APIs. And this is really said to be the next battleground of SDN. Now there are many definitions of SDN, but we'll use Gartner's because it's relatively broad but succinct and widely accepted. Gartner defines SDN three ways. First, the control plane decision-making authority for an SDN function is removed from the individual devices and is pulled into one centralized engine. Gartner gets more granular by then defining how communication takes place. So next they say the centralized engine is called an SDN controller, which means that it is really software code on a server. The communication between SDN controller and the infrastructure is done now through communication protocols called southbound APIs, or application program interfaces. Next, the communication that occurs between the controller and applications requesting an SDN function is done through a northbound API. Let's look at the definition in a model now. Okay, so here's a high-level view of an SDN architecture. You start with the application. This can be a business application or some kind of functional application. Then you have a northbound API that's really the communication link between the application and this control layer. The controller then processes the information. In other words, it understands what is happening in the application, and then based upon programming that you set, sends directions to the infrastructure via communication links called southbound APIs. The infrastructure simply takes the instructions and executes them. We'll now apply some terms to the architecture. Don't be alarmed with all the new terms. We're just familiarizing you with them. We won't get any deeper than that. At the application layer, network virtualization, VM mobility, and service chaining are examples of functional applications. Service chaining are really sequential services provided by the infrastructure, such as load balancing, firewall services, and WAN optimization. The most common programming code for northbound APIs is something called REST, which is widely accepted in the industry. Vendors have also created their own. Several controllers have been developed and are being used in closely monitored networks. Examples include VMware's NSX and controllers released by industry project consortiums such as OpenFlow Floodlight and Open Daylight Hydrogen. Commonly used elements for southbound APIs include netconf to modify networking device configuration and OpenFlow to modify its forwarding tables. The others are commonly used protocols for routing and management. The infrastructure layer really comes in two flavors. A white box is a generic dumb device that simply executes the commands of the SDN controller. Today these are primarily used at large service organizations like Google, where they've implemented a unique mix of distributed intelligence and OpenFlow control within their homegrown OS for the Andromeda Cloud, as it's called. An underlay means that you have an infrastructure with some sort of distributed intelligence upon which you overlay the data plane for the SDN function you're looking to enable. A common example of this is VMware's NSX overlaying VXLAN tunnels on top of existing networks to enable VM mobility across layer 3 environments. We have to address, really at this point, what problems SDN solves. And this is really a big industry question. The fact is there is no defined list, and in my own research I spent hours looking for a defined list, and there really is no de facto list of what SDN solves. So some people have said that SDN is a solution looking for a problem. Now, although this is an exaggeration, the SDN movement really came about gradually as a concept, so over the next few years there'll be a lot of effort toward mapping solution directions to business problems. The fact is, nobody really has a full grasp on where it's going, but most believe it will shape the industry in one way or another. So for our purposes, here's a compiled list from different websites. In looking at the list, there are really two themes that emerge strongly: complexity and agility. Now let's look at some key SDN technologies using network diagrams. Here you see the standard SDN model with applications on top, an arrow pointing to where the northbound APIs live, and an SDN controller interfacing into the network. The thing we want to bring out in this slide is that netconf is the de facto protocol for making network changes. This is what everyone is going to use to handle this function. Yang is the programming language for netconf. The most commonly known southbound protocol today is OpenFlow. OpenFlow is a newly released protocol for standardizing communications between a central SDN controller and network devices. It is the culmination of 6 years of work between Stanford and UC Berkeley. The OpenFlow standard is managed by the Open Network Foundation. Where netconf handles the configuration of the network, OpenFlow manages the forwarding plane centrally. There are a number of OpenFlow controllers out there. Floodlight, Beacon, and vendor-specific controllers are likely the most known. For OpenFlow to work, switches must be OpenFlow enabled. Open Daylight is an industry project that seems to have the greatest flexibility in its direction. As a market, we really don't know what SDN is going to look like, and the Open Daylight project is welcoming broad groups of contributors. The project scope is beyond just OpenFlow. As you can see from the diagram, Open Daylight is supporting multiple types of switch varieties and is open to a concept called abstract and delegate that we will talk about later. The northbound APIs are the most up in the air right now for mainly two reasons. First, most companies have been focusing on the southbound interfaces and infrastructure for functional applications like VM mobility and network virtualization. And second, we really haven't understood yet how deeply and in what ways application feedback can direct network performance. Likely the most advanced northbound API is open source software called OpenStack. OpenStack is targeted at the data center with the express purpose of facilitating the building of private and public clouds. The software centralizes the control of key elements of the data center, such as compute, storage, and networking. As long as OpenStack is supported in the device, the software consolidates multiple vendor environments. Now, Avaya has an operable OpenStack network API today and is continuing to develop it. Now that we have a good baseline regarding what SDN is and are familiar in general terms with some technologies, let's look at some models being promoted in the market today. What you see on screen right now is likely the most talked about model in the market. This model is device-based and represents what some consider the SDN pure play and is based on OpenFlow. The pros of this model is that it's theoretically sound. It's also open and offers the ability to do traffic engineering. The downside is that the controller must reinvent many of the functions that routing protocols do really well today. In fact, inventors of the protocol are backing away from this model a bit. The real key challenge to this model is answering the question, does this really remove complexity, or does complexity just shift from CLI command orchestration to programming orchestration? The next model is an overlay model. Here, an SDN controller is still deployed, but communicates with something called a hypervisor or a vSwitch. A hypervisor is simply software that controls virtual machines. So in this instance, the hypervisor controls servers in the data center and creates tunnels between them regardless of physical location. Now, as mentioned earlier, this model is actually available today. Now, the model is convenient in that it simply overlays the existing network and simplifies the movement of virtual machines between racks and data centers. So for this reason, IT staff who are being pushed to do something with SDN are taking this kind of non-committal approach, as it's fairly low cost upgrade to an existing vendor that requires no fundamental changes to anything else and has immediate value and productivity through enhanced virtual machine mobility. So they can check the SDN box while in reality waiting to see the broader direction of the industry before making any significant bets on technology. Now, however, there are some obvious downsides. The model does not actually remove complexity. In fact, it adds another layer on top of today's already complex network architecture. Troubleshooting becomes more complex as you now have to work out solutions between server and network roles. The hybrid model that you see on this slide allows direct SDN and hypervisor control. Like the prior model, it solves virtual machine mobility well and allows for a wider variety of control, but does not solve the underlying complexity issue. The final model is also a hybrid, but utilizes an intelligent infrastructure to which the SDN controller can delegate for native forwarding or as a dynamic underlay. The pros of this environment are that first, the key network functions are automated by the fabric, and second, there is great flexibility in terms of how the network is controlled. Third, the resources can be fully or partially virtualized. And fourth, there is no reinvention of what infrastructure already does best. The model's greatest critique is from the purists that state that this model does not fit the classic SDN definition since the infrastructure is already automated. With the foundation of technologies and models covered, let's turn to Avaya's direction for software-defined networking. There is a long-standing culture in the R&D group of Avaya that embodies the philosophy that delivering the best technology possible is better for customers than delivering inferior technology, even if that technology is more popular at the time. Avaya's direction with SDN is no different. What will be shown in the next group of slides is what Avaya believes is the absolute best direction for most customers in the market. The first component of Avaya's direction is actually to solve the fundamental issues of complexity in the market. We'll cover this in more detail on the following slides. Next, implement truly flexible cloud control of infrastructure elements from server to end device. Third, automate the services layer and allow real-time application feedback to dictate the actions of the network forwarding plane. Let's look at each of these directions in more detail. There is no solution available in the market today that solves the issues of complexity and time to market shortfalls better than Fabric Connect. Fabric Connect not only simplifies implementation and troubleshooting, but effectively automates the setup, teardown, and forwarding functions of the network. It would take years and lots of money to program what Fabric Connect already automates today. Uniquely, Fabric Connect extends from data center to device. The bottom line is that there is no better foundation for SDN than Fabric Connect. Now, for more information on Fabric Connect, visit avaya.com. Follow the paths listed on the slide. Go to the capabilities menu at the top, then technology, network virtualization, and resources. Or on the Avaya Sales portal, click on the tile on the right-hand side of the page called Fabric Connect Sales Play. Next, focus on the end-to-end infrastructure. Leverage the OpenStack APIs to gain greater agility in the creation of end-to-end cloud-based services in few steps, as well as the work being done in OpenStack Congress to automate the service chain. This area will continue to grow and mature as OpenStack and Avaya partners to continue to innovate within this open environment. In addition, focus on the automatic attachment to Fabric services for non-networking elements like vSwitches, load balancers, security devices, as well as endpoint devices like phones, security cameras, medical devices. This allows further simplification and agility of the entire infrastructure when working with Avaya and our ecosystem partners. This area is the least developed and has the most exciting opportunities for the future. Here is where Avaya customers can leverage in-house and open source tools to automate the creation of cloud services through direct interaction with the application layer. Avaya sees the promise of this area dependent upon deep and intelligent policy integration, which Avaya already has a great foundation of technology for. We'll conclude today's session with a recap of Avaya's strategy by revisiting the general SDN model spoken about earlier. Starting with the end in mind, superior application performance has to be the end result of any SDN evolution. As a real-time collaboration and networking provider, Avaya will make this area the primary focus. To do this, Avaya is an active member of the Unified Communications Internetworking Forum and Open Daylight. Avaya will be a rich contributor to these organizations. Avaya is working on a cloud orchestration suite that will combine Avaya tools and industry software and controllers to uniquely assess application performance and delegate proactive instructions to the infrastructure layer. NetConf will be the communication medium to Fabric Connect, along with support from other APIs to integrate with diverse environments and fully realize the simplicity and time to service gains that come with an automatic core. In conclusion, I'd like to leave you with three overarching thoughts. First, SDN is an operational philosophy and a community that's in its early stages. The market is far from shaping SDN in its final form, and we believe that it will impact the market in many positive ways. Second, Avaya's SDN direction gives you the ability to participate in the benefits of SDN today, while setting you up for the best foundation for SDN in the future. Third, customers should move at their own pace. As value is demonstrated, investigate, and then implement. Thanks for your time and attention, and good selling.